Namaskara. So the question is like this. Today's video, in this video we are learning this one. Obtain the expression for energy stored in the charged capacitor. Capacitor no purpose to store the energy, electrostatic energy. Okay, how much of energy stored ಅನ್ನೋದು ನಾವು ಮಾತಾಡ್ಕೋಬೇಕಾಗ್ತದೆ. ಇಲ್ಲಿ ನಮಗೆ ಗೊತ್ತಿರಬೇಕಾಗಿರೋ ಬೇಸಿಕ್ಸ್ ಏನಂದ್ರೆ ಫಸ್ಟ್ ಥಿಂಗ್ work done against any system is stored as a potential energy. Therefore, the work done due to a charged particle is given by work done is equal to Q into V. ಇದೊಂದು ಗೊತ್ತಿರಬೇಕು. And we know that C is equal to Q divided by V or V is equal to Q by C. Basic definition. Okay. ಆಮೇಲೆ ಇನ್ನೊಂದು ಏನಂದ್ರೆ ಯಾವುದೇ ಕೆಪಾಸಿಟರ್ when we connect it to a battery doesn't instantaneously complete a charge ಆಗಲ್ಲ. Unless and until it reaches something what we call it a steady state. So ಅದು ಚಾರ್ಜಿಂಗ್ ಹೆಂಗಾಗತ್ತಂದ್ರೆ Q versus T ಅಂತ ನಾವೇನಾದರೂ ಬರ್ಕೊಂಡ್ರೆ slowly rises and it will come to a constant. Okay, so ಇದನ್ನ ನಾವು steady state ಅಂತ ಕರಿತೀವಿ. Unless and until it comes to steady state, it doesn't have a complete charge, ಅಂದ್ರೆ complete potential raise ಆಗಲ್ಲ. So ಇದಿಷ್ಟು basics ಇಟ್ಕೊಂಡು now we'll solve this one. So let us consider a parallel plate capacitor whose area is A and it is separated by distance D. And let us assume that it is connected to a plate and on battery potential V connect ಮಾಡಿದ್ದೀವಿ. At some state, at some intermediate state, let us assume that this is charged to plus Q and this is charged to minus Q. Okay, ಇದನ್ನ ಯಾವುದೋ ಒಂದು ಬ್ಯಾಟ್ರಿಗೆ ಹಿಂಗೆ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ದೀವಿ ಅಂತ ಅನ್ಕೊಳ್ಳೋಣ. Sorry. Okay. So immediate ಆಗಿ ಇದು ಹೆಂಗಿದ್ರು ಕೂಡ ನಮಗೆ ಇಮಿಡಿಯೇಟ್ ಆಗಿ ಇಟ್ ಡಸಂಟ್ ಗೆಟ್. ಸೊ ಅಟ್ ಸಮ್ ಇನ್ಸ್ಟೆಂಟ್ ಆಫ್ ಟೈಮ್ ಇಲ್ಲಿ ಏನಾಗಿದೆ ನನಗೆ ಪ್ಲಸ್ ಕ್ಯೂ ಇದೆ ಮೈನಸ್ ಕ್ಯೂ ಇದೆ. ಲೆಟ್ ಅಸ್ ಅಸ್ಯೂಮ್ ದಟ್ ದ ಪೊಟೆನ್ಷಿಯಲ್ ಇಟ್ ಹ್ಯಾಸ್ ರೀಚ್ ಟು ವಿ ಪ್ರೈಮ್, ಇದು ವಿ ಇದೆ. ಸೊ ಇಲ್ಲಿಂದ ಈಗ ಏನಾಗ್ತದೆ ನನಗೆ ಪ್ಲಸ್ ಕ್ಯೂ ಡಿ ಕ್ಯೂ ಪ್ಲಸ್ ಡಿ ಕ್ಯೂ ಇಸ್ ಟ್ರಾನ್ಸ್ಫರಿಂಗ್ ಫ್ರಮ್ ದಿಸ್ ಪ್ಲೇಟ್ ಟು ದಿಸ್ ಪ್ಲೇಟ್ ಥ್ರೂ ಅ ಡಿಸ್ಟೆನ್ಸ್ ಆಫ್ ಡಿ. ಓಕೆ, ಇದು ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಡಿ ಅಂತ ಡಿಸ್ಟೆನ್ಸ್ ಅಂತ ಅನ್ಕೊಂಡ್ರೆ ಇಟ್ ಇಸ್ ಟ್ರಾನ್ಸ್ಫರಿಂಗ್ ಥ್ರೂ ಅ ಡಿಸ್ಟೆನ್ಸ್ ಆಫ್ ಡಿ. See, energy stored is nothing but work done against the system. Here also this is doing a work in transferring dq from this to this against this potential. V prime potential ಗೆ against ಆಗಿ ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಚಾರ್ಜ್ ಟ್ರಾನ್ಸ್ಫರ್ ನಡೀತಾ ಇದೆ. Therefore, dw is equal to V prime into dq. Therefore, W is equal to integral of V prime into dq, or W is equal to integral of V prime can be written as charged at that instant divided by capacitance. Capacitance is a constant. Okay, it does not depend on the charge and potential depend ಆಗಲ್ಲ dq. ಎಲ್ಲಿಂದ ಎಲ್ಲಿವರೆಗೂ initially it has no charge, 0 ಇಂದ it will have a maximum charge of plus q. So this work done against the potential is stored as a potential energy 1 by C integral of Q dq from 0 to capital Q. Therefore, U is equal to 1 by C integral of Q can be written as Q square divided by 2, because we know that integral of x dx is equal to x square by 2 plus c, but ಇಲ್ಲಿ definite integrals ಆಗಿರೋದ್ರಿಂದ we don't use plus c. From where to where it has been? From 0 to capital Q. This implies that u is equal to half q square divided by c. So, ನಮಗೆ final expression ಏನು ಬರೀಬಹುದು? U is equal to half q square divided by c, one expression. But Q is equal to C into total potential V. Therefore, U can also be written as half CV square, which actually represents us the energy stored inside a parallel plate capacitor. I hope you understood this one. Thank you.